Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nuruddin bin Johan and my matrix number is AE180041. So now I'm going to present the progress for my final year project 1, which is about the smart wireless charging with charge monitor for AUTOGATE system battery. And then we will discussing step by step, starting from the project background until the end of the discussion, which is the conclusion. And then we will proceed to the first slide, which is about the project background. So basically, this project is mainly implemented from the concept of wireless power transfer. And then in order to go further to the next level of discussion, we have to know what is wireless power transfer concept actually is. The person who responsible for the idea or concept of wireless power transfer was Nikola Tesla. He proposed the concept of wireless power transfer in the year 1899. Since then, many scientists have been working to make his vision a reality. And then the wireless power transfer system allow power to be transferred from one electrical network to another without the needs of wires or exposed contacts. For a larger number of diverse applications, this feature is highly advantageous and in certain cases has enabled a new application to be realized. And then the wireless power transfer is one of the hottest topic being actively studied, and it is being widely commercialized. In particular, there have been a rapid expansion of WPT in mobile phone charger, stationary charging EV, and also the dynamic charging EV. And basically, this project is focused on the implementation of WPT concept to an hardware and to charge an AUTOGATE system battery. And then we will go through the problem statement. So the first point from the problem statement is about the mobility. So the biggest disadvantage of wired technology is that it lacks the mobility that wireless technology provide. We are physically limited to reach of the cable, whereas the wireless technology allow user to move great distance freely and without hassle. And then the another physical constraint of wired technology is that the wires can be easily damaged, which is not a large of a concern with wireless technology. Exposed cables are susceptible to everyday abuse from things such as cleaning, and wires that are exposed and not properly laid may also pose a tripping risk, not only damaging the cable but also potentially sending someone to the emergency room. And the damaged wires may have to be completely replaced. The third one is about the cost. The cost of wired technology can be quite expensive. And then the last one is about the expansion. The scalability of wired technology can be both costly and time consuming. And then we will proceed to the next slide, which is the objectives. So the first objective is to design and produce a hardware of smart wireless charging with charge monitor to charge 12 volt 7 amps hour AUTOGATE battery. And then the second one is to control the battery charging system and voltage using Arduino software, or we can say Arduino IDE, particularly AVR family microcontroller, or specifically ATmega 328P microcontroller. And then the third one is we want to investigate either the system can produce an exact output, which is DC 12 volt efficiently. And then we will go through the project scopes. And then the first project scope is to design the circuit by using Proteus X professional software and come out with PCB layout. And then the second one is we want to model a wireless battery charger with the help of two coils, where the primary coil act as a transmitter and the secondary coil receive the power to run the load. And we also use AC 230 volt and 50 hertz supply that will be supplied to the primary coil as an input, and the secondary coil will develop a high frequency of AC 12 volt. And then we also have the bridge rectifier that will rectify the circuit by converting AC to DC. And we also have the DC voltage regulator, or specifically IC7812, which will keep giving the constant DC supply to of 12 volt to the AUTOGATE battery. And then the last one is we will do the coding in Arduino IDE using Arduino Uno that consists of ATmega 328P in order to control and monitor the voltage and also the battery percentage of the rechargeable battery, or the AUTOGATE battery. Okay, we will proceed with the methodology of the project. So basically, the flow of the project consists of four phases, which is the phase one is about the project planning, phase two is about the project design and circuit simulation, and phase three is about the development of a hardware. The phase four is about the result analysis and also the documentation. And we will go through to the first phase, which is the project planning. So first of all, the title for the project must be chosen and it must be suitable. The title that have been chosen is Smart Wireless Charging with Charge Monitor for AUTOGATE System Battery. And this project focusing on implementing the concept of WPT into a real life and able to charge the rechargeable battery like AUTOGATE System Battery, and also able to monitor the battery charges and voltage. And from the idea of the project, the objective and the scopes of the project must be identified. It can be said that the objectives are to design and produce a hardware of smart wireless charging with charge monitor to charge 12 volt 7 amps hour AUTOGATE battery and to control the battery charging system and also the voltage by using the Arduino IDE, particularly AVR family microcontroller. And the scope for this project are focusing on modeling wireless battery charger with the help of two coils, where the primary coil act as a transmitter and the secondary coil receive the power to run the load. Coding in Arduino software or Arduino IDE using a AVR family microcontroller to display voltage and monitor the battery charges. And the last one, to test the system, either it can charge the AUTOGATE battery system until it reach 100%. Then to find as many past researchers as could be. It is essential for the literature review by search for the research paper on article. From there, the idea, including the software and components, can be gained and useful for this project. And then the second one is the second phase is about the project design and circuit simulation. So in this phase, a sketching or block diagram will be developed in order to understand the connection for each component. After that, a circuit simulation for smart wireless charging with charge monitor for AUTOGATE system battery will be designed, embedded with the Arduino Uno microcontroller. Before running the simulation, the coding must be developed by using Arduino IDE to ensure that the microcontroller can give the instruction for the process of the system. After finishing the coding part, the system can be run to ensure the system simulation work well or not. If the simulation are not running successfully, the analysis of the error must be checked to fix it. If the simulation running successfully, then the process can proceed to the phase 3, which is focusing on the development of hardware. So in the phase 3, which is the development of hardware, the development of hardware must so in this phase, the development of hardware must be done. The first step must be focused on the wireless charging system itself. Then it must be integrating with the microcontroller, which is the Arduino Uno, that consists of Atmega 328P microcontroller. So basically, as you can see from the screen, that is the block diagram for the design, for the system design. And AC single, so based on the block diagram, we can see that we have the AC single phase 230 volt with 50 hertz of frequency supply is fed into the high frequency transformer, which output 12 volt AC with an extremely high frequency of up to kilohertz. There are different blocks that are connected to each other in the form of electronic devices inside the HF or high frequency transformer. And then there's device rectifier, capacitor, transistor, inverter, or so on. And the rectifier is linked to the AC supply to rectify or convert it to DC, and the capacitor used to link to filter out the pulsing DC, resulting in a smooth and consistent DC. And the capacitor basically make DC ripple free. In the circuit, another transistor is connected to amplify the frequency signal. Here is where an inverter is attached to convert DC to 12 volt AC, which come out of the high frequency transformer as output. And the 12 volt AC with a frequency of 25 kilohertz then flow to the transmitter coil, where flux is created around the coil. As a result of the induced EMF in the receiver coil, the current begins to flow in the circuit, which is AC and has a high frequency. And the bridge rectifier, which is linked adjacent to the receiver coil, rectify the AC current by converting it to DC. and following that, a capacitor is attached to filter the pulsing DC into a smooth DC, which is then output. A voltage regulator is also attached to provide a steady DC supply of 12 volt to the AUTOGATE battery, which serve as a load, but it will pass through the Arduino Uno first, which consists of Atmega 328P microcontroller inside it, and that functioning to monitor the battery charges and voltage. And the last phase is about the result analysis and documentation. In this phase, all the data and result must be analyzed for the discussion. Every discussion will be explained with a lot of details on them. Then documentation must be done for the record that approve that this project work successful. Okay, we will proceed with the next part, which is about the preliminary result. So basically, in this final year project 1, I want to produce a PCB that the connection is starting from the high frequency secondary coil until to the load, which is the battery, or we are using the AUTOGATE battery. And then the circuit or the simulation will be conducted in the Proteus X professional software, and the result can be seen throughout the screen, and we will go through the simulation in the software. I will show the result from the simulation in Proteus X professional software. So, and I will explain a little bit about the system. So basically, we have a transformer and also the supply here. This is for demonstration purpose only. So the transformer here will step down the voltage to 12 volt in order to be supplied to the whole system, but this is just to replace the secondary coil from the real system. Since the secondary coil will receive a 12 volt in AC, so I put the I put the supply and also the transformer here in order to power up the system. And then we also have the bridge rectifier that will converting the AC to DC, and we also have the smoothing capacitor to smoothing the voltage, and we have the IC regulator here in order to give a constant DC 12 volt to the load or to the AUTOGATE battery. And we also have the resistor here, 1k ohms resistor here, in order to limiting the current that pass through the LED in order to prevent it from burning. And we also have the DC voltmeter here in order to observe the output voltage, and it's just for a demonstration purpose only. But at real life, this is our battery. The AUTOGATE battery will be placed here, and the circuit will go the connection will be the connection will be connected to the Arduino Uno then. And we have to know that the Arduino Uno will be operating just only when 5 volt supply is given to it. Since the voltage that come out from the circuit is 12 volt, we have to use voltage divider rule in order to obtain 5 volt at output here to be given to the Arduino Uno to operate. And then we also have the LCD here. LCD here to display some parameter like battery percentage and also the voltage. And for the Arduino Uno here, the coding that being inserted into the Arduino Uno to monitor battery charges and also the voltage is this. This is the coding that I developed in the Arduino IDE. So I will click the run button here to observe the result. So we can see that the LED green here is turned on, and we can see the voltmeter here shows 12 volt, and this means that our objective is achieved, since we have to get the 12 volt at output of the system. And the display here also achieve the target, which it shows the value of voltage and also the battery percentage. And then we will proceed to the PCB layout. So this is the PCB layout that already produced from previous circuit, but this is in two-dimensional view. And this is the 3D PCB layout. So we will more understand about the connection and the sequence of the components. in the PCB. So as a conclusion, the development of smart wireless charging with charge monitor for AUTOGATE system battery can be said nearly finished and successfully developed from the simulation. Some of the objectives of this project have had been achieved, and Arduino Uno with Atmega 328P microcontroller able to monitor the battery charges and also able to display the voltage. The simulation from the Proteus 8 professional software also shows the great result since the target output is achieved, which is 12 volt in DC. And that's all from me for my FYP1 progress presentation. Thank you.